The value of scatter plots. Introduction. Authors frequently report correlation or regression statistics to quantify the linear association between two numeric variables. These statistics always should be accompanied by scatter plots. Scatter plots visually display the relationship between two variables and instantly provide the reader with key information such as the shape of the relationship, the sample size involved, and the influence of outlying data points. Among all the forms of statistical graphics, the humble scatterplot may be considered the most versatile, polymorphic, and generally useful invention in the entire history of statistical graphics. Write Michael Friendly and Daniel Dennis. This article gives tips for drawing scatterplots and also gives 3 examples of how scatterplots can reveal problems with correlation and regression statistics. Tips for drawing scatterplots. Lines on plots can fool the eyes, as illustrated in Figure 1. This figure shows two variables, x and y, that are completely unrelated. To fool your eye, I added arbitrary diagonal lines to the plot. The lines make it appear as if there is a positive relationship between x and y, or a negative relationship. But when you remove the lines, it becomes easier to see that x and y have no relationship. Commonly, when drawing scatterplots, authors will superimpose a linear regression line to help visualize the relationship between the variables. These regression lines, however, can trick your eyes in the same way, causing you to perceive stronger relationships than actually exist. Authors also should avoid manipulating the axes in ways that visually exaggerate the effect. Examples of such manipulations include stretching or truncating the x or y axes. Example 1. Scatterplots reveal nonlinearity. Correlation coefficients and linear regression statistics assume that the relationship between two variables is linear, follows a straight line. This assumption is often violated, however, and should be checked by plotting. Example 2. Scatterplots reveal small sample sizes. Unlike box plots or bar charts, scatterplots show each individual data point, which gives readers more insight. Scatterplots visually remind readers of sample size limitations and reveal instances when a purported correlation rests on just a handful of observations. In a 2014 study, 13 acne-prone young men consumed varying amounts of cocoa at baseline. A week later, a dermatologist measured their facial acne. The authors concluded that there was a medium-strength positive Pearson correlation coefficient between the amount of chocolate each subject consumed and the number of lesions each subject developed on day 7. The authors failed to mention that this correlation was not statistically significant. Commendably, they did provide a scatter plot of their data from which I was able to extract the individual values and replicate their plot. At first glance, there appears to be some moderate correlation between the two variables, but removing the regression line and adding a smooth line reveal that the relationship is unimpressive. Visually, it is apparent that without the 2 data points on the lower left corner, the 2 men who had no chocolate and developed little or no acne, there would be no relationship between the acne and chocolate. Note that the authors made the x-axis longer than the y-axis, which may also have visually exaggerated the effect. Example 3. Scatterplots reveal influential outliers. Outliers in the data can inflate correlation coefficients and linear regression statistics even when the sample size is relatively large. When there is an extreme outlier, the data are effectively reduced to 2 points in space, the outlier and the cloud of other data points. Connecting these 2 points form a line. However, the line is determined by the position of the outlier rather than the true relationship between x and y. Conclusion. Scatterplots are a fundamental graphing tool and are essential when reporting linear correlation and regression statistics. These statistics evaluate linear associations and will miss nonlinear relationships, which scatterplots can reveal. Scatterplots also can reveal when a statistic is unduly influenced by a few data points because of a small sample size or the presence of outliers. Authors are advised to superimpose smoothing lines on scatterplots rather than the traditional linear regression lines, at least when first inspecting the data. Readers should be skeptical when authors report correlation and linear regression coefficients but fail to provide scatter plots. When plots are provided, readers should examine them carefully to judge whether the reported statistics accurately reflect the true relationship between the variables or are misleading due to nonlinear relationships, small sample sizes, or outliers.